In the last lecture, we discussed about the continuous random variable and some of the properties, and discussed about the probability density function, the cumulative distribution function, and also regarding the mean of the random variable, variance, moment, mean square value, and the standard deviation. Okay, so today we will see some of the important probability density functions which are very common in which are very common in many engineering problems. Okay, so one of the important probability distribution function density function is the normal distribution, or first of all we will discuss about the Gaussian distribution. Okay, so I will just refresh you what is the density function. So in the last class we discussed about the probability density function. Okay, density function. Okay, it is usually denoted as fx of x. Okay, where x is showing the random variable, and this is the x is the value taken by the random variable x. Okay, that means x takes the value small x. This is usually we will be usually using this representation. Okay, and we also discussed about the probability, that means a cumulative distribution function. Okay, distribution function. So this also we have discussed in the last lecture. That means the CDF of the continuous random variable, or this is having another name. It's also known as probability distribution function. Okay, function. That means we will use the capital letters PDF for this. Okay, so CDF and CDF and capital PDF, that means capital PDF, both are same. Okay, these are same anyway, but the probability density function is usually denoted by small letter PDF. Okay, this is the probability density function. And what was the relation between the density function? The density function, or the cumulative distribution function, was usually represented by fx of x. It is nothing but the probability that the random variable x takes the value less than or equal to x. Okay, this is the, and what is the relation between these two? Okay, you can find fx of x by taking the derivative with respect to x of the distribution function. Okay, fx of x. So this was the relation between these two. Anyway, we will see. So we will be mainly focusing on this term, that means the density function, that means probability density function. And this one, I told you, this was the capital PDF, or it is also known as CDF. Okay, two names are there. Okay, so we will mainly focus on this PDF. Okay, so we will mainly focus on PDF. So what are the different shapes of PDF which are very common in many engineering problems? So first of all, we will discuss about one of the important PDF which is usually coming in most of the situation, in error analysis, many estimation problems, etc. Okay, so that is nothing but the Gaussian distribution. Okay, Gaussian distribution. Even though we say distribution, it is actually PDF. So Gaussian distribution. Okay, so we are talking about the PDF, that is small letter PDF, the probability density function. Okay, density function. That means we are talking about fx of x. Okay, and this fx of x, for the Gaussian distribution, the fx of x is nothing but 1 by square root of 2 pi into sigma square. Okay, sigma square is inside the square root, into exponential of minus of x minus mu x. Okay, the x minus mu x the whole square by 2 sigma square. Okay, sigma x square. Okay, sigma x means sigma x is nothing but the variance of the random variable, variance, and mu x is nothing but the mean of the random variable x, mean of the random variable x, variance of the random variable x. Okay, so we are talking about the random variable x. Now you can find easily the fx of x by, it is nothing but the probability that x takes the value less than or equal to x. How you can find it? You can find it from minus infinity to x. Okay, or the probability fx of t, I will use the notation t here, then that will be better. So fx of some t is nothing but the probability that x takes the value less than or equal to t. It is minus infinity to t fx of x dx. So this is how you can find the distribution, cumulative distribution function. Okay, and this is the main equation. That means this is the main equation. You have to remember this equation because you can, this is a very popular equation, and that's why, and it is mainly used in many engineering application. Okay, so we will see what is the shape of this fx, small fx, the PDF. Okay, so we will talk about the PDF, small PDF, fx of x. It is having a shape something like this. It is having a bell shape, you know bell, right? So this is having a bell shape. This is the shape of this PDF. Okay, so this is the shape of this graph. That means this is fx of x is equal to 1 by, okay, 1 by square root 2 pi sigma x the square into e power minus of x minus mu x the whole square divided by 2 sigma x square. And I will say my origin is somewhere here. Let's say this is my origin and this is my x-axis, this is my x-axis, and this is my fx of x. Okay, my origin is 0 here, and maybe you can say this is minus infinity and this is going to plus infinity. Okay, plus infinity. And then you may be asking, what about this peak point? This is the peak point. Actually, this peak point is nothing but your average mu x. So mu x will be your peak point. So at mu x you will be getting maximum, because you can see the function is something like x minus mu x. When x become mu x, that means this function is nothing but x minus mu x. That means when x is equal to mu x, you will get x minus mu x as 0, right? So then if x is equal to mu x, then you will get 0. That means e power minus 0 means e power 0. E power 0 is 1. So that's why you are getting a maximum value at mu x. Okay, and the spread, actually we will call this spread, we will call this as the spread of the random variable. I will show you. This is the spread. Actually the spread, it is nothing but the standard deviation sigma x. So sigma x square or sigma x is depending upon your spread, actually sigma x square. Okay, so I will show you different graphs anyway. You have the PDF something like this. This PDF, for example, you have the PDF something like this. So this is your sigma x square and this is your fx of x as the Gaussian distribution. Okay, Gaussian distribution, and this is your maximum value, and suppose this is 0, that means your mu x is equal to 0. So this is the case where mu x is equal to 0. When mu x is equal to 0, then you have the equation something like that, some 1 by square root of 2 pi into sigma x square into e power minus x square by 2 sigma x square. Okay, so this is the graph when mu x is equal to 0. Now there are some other case which this is an example. Okay, this is another example we can have as mu x is not is equal to 0, say, but the standard deviation is 1. Sorry, So this is another graph. Okay, so you have some mu x. Anyway, this is your x, and this is your x, and this is your fx of x. So fx of x actually is nothing but your sigma x square. Suppose it's equal to 1, then it's nothing but 1 by square root of 2 pi into e power minus of x minus mu x the whole square divided by 2. Okay, because here sigma x square is equal to 1. And there is another example 3, that means you have mu x and sigma x square both has you have something like this one. This is going to 0 here, and here it's going to 0 minus infinity, and x and fx of x. In this case, I am assuming my sigma x square is equal to 1 and my mu x is equal to 0. That means I have two things now. Mu x is equal to 0 and sigma x square is equal to 1. That means 1 by square root of 2 pi into e power minus x square by 2. This is known as the normal distribution. We will call this as the normal distribution. So normal means actually it is a special case of the Gaussian distribution, normal distribution. Okay, so why we are calling it as the normalized? It is actually normalized. That's why it is a normalized Gaussian distribution. That means in normal distribution, it is nothing but the Gaussian distribution with sigma x square is equal to 1 and your mean is equal to 0. Okay, that means it's normalized. Okay, now what will happen if you have another thing like if sigma is, for example, you compare two Gaussian distribution. One is like this, okay, and another one something like this. Okay, so this is having some sigma x1 square, and this is having sigma x2 square. X1 and x2 are two different random variables. So fx1 of x and this is fx2 of x. Okay, now you see here this is your x and this is your random this is your probability density functions. Okay, now you can see this is having more spread. Okay, so the variance of x2, the random variable x2, this is for the random variable x2 and this is for x1, the variance of x2 is greater than the variance of x1. That means the spread of x2 is greater than the spread of x1. Okay, that means sigma x2 square is greater than sigma x1 square. So the variance means actually the spread of the random variable. You can see how much it is spreaded. So the spread here is for the first case is less when compared to the second case. Okay, so the second case is having more spread. So this is a very, very important notion. Now we will see how the probability density function, the probability distribution function will be looking like. Okay, so we have the density function. We have the density function something like this. Okay, now this is your this is your 0 and this is your mu x and this is your fx of x, and this is having the form, this is sigma x1 sigma x square, so 1 by square root of 2 pi into sigma x square into e power minus of x minus mu x the whole square divided by 2 sigma x square. Okay, now you know that the distribution function is nothing but your cumulative distribution function, or we can call it as capital PDF, is nothing but fx of x is nothing but the probability that x takes the value less than or equal to x. That means how to find the probability from the density function. That means you have to integrate your density function. Let's say I will use another variable that's for the convenience. So fx of t is nothing but probability that x less than or equal to t. So I will take this 0 to t. I have to just integrate the fx and I can get the probability that x less than or equal to x. So this is the by definition. So if I have a PDF, this is nothing but the small letter PDF. If I have a small PDF, that means the probability density function, I can easily find the probability. This is the probability, actually the probability, or I can find the distribution, the CDF, easily. Okay, so how it will be looking like if I integrate this thing? So integrate. So what will be? It will be, you have the variable t. Okay, then fx of t will be looking like, you see this is starting from minus infinity and going to plus infinity. When it reaches plus infinity, I told you, you are finding the area from minus infinity to plus infinity. So if you integrate under fx of x, that means if you integrate for all values of x, integrate from minus infinity to infinity, fx of x dx will be always 1 anyway. So finally this will be going to a value anyway. At plus infinity it will be going to a value plus 1, and at minus infinity, if something before minus infinity, means it's 0, because there is nothing here. You see here it's going to 0, so if you integrate also you will get 0. But when you move on, you have the area here, right? You have a lot of area here. So when you reach this point, you have this much area. So when you reach this point, you have a lot of area from suppose you reach the point here t, suppose your t is here, so you have lot of area from minus infinity to t. That means your area is increasing, and it will be moving to a value, and finally it will go to plus 1. Okay, so this will be the shape. Okay, this will be the shape. So this I have to give you one important point, is that okay, I will draw it in a little bit. This will be like this. Okay, this will be like this. Now I want to show you one important point, that suppose at mu, at average, that means suppose your average is here, you will get the total area under this curve. The total area under this curve is equal to 1. So at mu x, what will be the area? Because you are covering only half of this, the area will be half of 1. So you will get at mu x, you will get this value at mu x, at mu x you will have the value half. Okay, and this is going to 1 anyway. So at mu x you will be getting a value half. Okay, so this is the characteristics of the probability distribution function, or the cumulative distribution function, fx of x. So fx of x is nothing but fx of x, or fx of t. We are talking about t, the variable t, fx of t. Okay, so that's it. Or we can say in general fx of x, you can use any variable name. Okay, that doesn't matter. So if you know how to find the mean of this random variable, mean is nothing but, I told you, mean of a random variable is mu x, is nothing but the expected value of the random variable. I told you minus infinity to infinity into x into fx of x dx. Okay, so that we will get for this Gaussian distribution, minus infinity to infinity, x into 1 by square root of 2 pi into sigma x square into e power minus of x minus mu x the whole square divided by 2 sigma x square dx. If you integrate this, you will get exactly mu x, this guy. Okay, similarly you can find the variance. Sigma x square is nothing but the expected value of x minus mu x the whole square. So you have to integrate this minus infinity to infinity, x minus mu x the whole square into fx of x dx. So this you will get exactly sigma x square. Okay, so you have to substitute your fx of x here, then you will get exactly. I will show you one more step here. This is integral minus infinity to infinity x minus mu x the whole square into 1 by square root of 2 pi into sigma x square into e power minus of x minus mu x the whole square by 2 sigma x square dx. This you will get as exactly sigma x square. Okay, if you integrate this, I am not going for the proof. So this is regarding the variance of the random variable. I hope this is clear to you. So this is very, very important. You have to remember this formula and all this derivation and all these things. Okay, exactly, don't miss any point. So Gaussian distribution is over. Okay, now we have not only Gaussian distribution in wireless communication system. For analyzing the wireless communication system, we have other distributions also. So one of the important distribution is nothing but the Rayleigh distribution. So we will see some more continuous distributions, like Laplacian and Rayleigh distribution. Okay, these are all the different distribution. The first one actually is the uniform distribution. You can see this is the uniform distribution, UD. Actually we will call it as UD, uniform distribution. Uniform distribution means you can see the density function will be something like this. It will take this form. That means it is between, suppose a uniform distribution is defined between A and B, then it will be always uniform, constant. Okay, between A and B. Now how to find the amplitude? You know that the total area will be equal to, the total area is equal to 1. So this is fx of x for the uniform distribution. Area is equal to 1 means this width is nothing but b minus a. So this height will be 1 over b minus a. So then only you will be sorry, not this one. So this height will be 1 by b minus a. So if you take the area, that means 1 by b minus a into b minus a, this will be equal to 1. That's how we can find it. Okay, now another distribution is, so for the uniform distribution, the average expected value is nothing but a plus b by 2. If you know a and b, you can find easily the expected value. And the variance is b minus a the whole square by 12. Okay, so this is another thing, that is the moment generating function. This I will discuss later. That means this we will discuss later. And another random variable that I am showing here is the exponential random variable. The exponential random variable will take the PDF in this form. It will be like an exponential. Okay, so it is having lambda into e power minus lambda x, and the expected value, that means the average is 1 by lambda and the variance is 1 by lambda square. Okay, you don't want to remember all these things, so remember this one, remember the uniform distribution and the Gaussian distribution. Okay, and another is the Gaussian that we have already discussed. Now the Gaussian random variable, this you can see here, it is denoting sigma, because the sigma is you can also represent the Gaussian random variable like this, 1 by square root of 2 pi into sigma x square, okay, into e power minus of x minus mu the whole square by 2 sigma x square. Okay, you can also represent like this. Okay, this is what we have seen, sorry, this is what we have seen, but you can also represent, if you remove this square, then you have to remove the root from the sigma. Okay, then you have to write the sigma outside the root, sigma x, like this. So that's what here it is written like this. Okay, you can see. And this is the mean. Okay, here mean is m. We have used mu x, so mean is also represented by m. So mean mu x is also represented as m. Okay, and sigma x square is also represented as sigma square. Okay, now another thing is the gamma random variable. This is the distribution. Okay, and this gamma, you can see this is a gamma function. Okay, this gamma function, this is a gamma function, gamma function. Okay, so anyway, this is not so important, not important for us now. Okay, if it is required I will give. Anyway, this is the gamma random variable, and we have a few more random variable which is known as Laplacian random variable. So it will be looking like this x, this is minus infinity to infinity, so it will be double exponential, something like double exponential. Okay, so that's this equation is showing. Okay, double exponential, and the area under all this kind of random variable, all the area under the PDF of all random variable will be always 1. Okay, then another one is the Rayleigh random variable. This is x, but you see here the Rayleigh random variable is having a distribution like this. The Rayleigh distribution is a distribution with only positive values for x, only positive values for x, only positive values for x, positive values for x. Okay, all x are having positive values. There is nothing like negative here, nothing. This is minus infinity, but here is nothing. Okay, the distribution value is 0. Actually, density function is 0, and this is your fx of x, and fx of x will take this form. Okay, and the mean of the random variable is this one, and this is the variance of the random variable. So the mean is nothing but your mu x, and the variance is nothing but sigma x square. Okay, so this is, so it is having a parameter alpha. You can see the Rayleigh distribution is having an important parameter alpha. Alpha is the parameter for the Rayleigh distribution. Okay, I hope it is clear to you. So in order to define the probability, or in order to define the characteristics of a engineering system or a stochastic engineering system, instead of simply defining the probability, we will define its characteristics by using the density function. So if you are analyzing a system, an engineering system, okay, which is having some input and an output, and it is having lot of parameters inside the systems, and these are suppose random parameters. Suppose these are random in nature, that means these parameters are random in nature, or we will call this random parameters. So to characterize the system, so to characterize the system, instead of using our just simple probability theory, we will use the probability density function. So now you got what is the importance of this PDF. So we will use this guy, okay, because if you know this characteristics curve like this, maybe this shape or maybe this shape, according to that you can completely characterize your random parameters. So by using this PDF, you can characterize the random parameters, and now you have something, a very strong foundation regarding how to handle the stochastic engineering systems. So we are talking about the stochastic engineering systems, and for handling this stochastic engineering systems, this is random systems, okay. So stochastic engineering system, we need to firstly we should have a characteristics like its PDF, okay. Otherwise we should have at least some idea about the PDF or what is the shape of the PDF. If we know that, we can manipulate the system response, okay. So that is the idea. So we will see some problems. P1. If P of x is equal to x into e power minus x square by 2 for x greater than 0 and is equal to 0 for x less than 0, then show that P of x is representing a PDF, okay. So we have something like P of x which is given. I am going to write the answers. So P of x is given that x into e power minus x square by 2 for x greater than or equal to 0 and equal to 0 for x less than less than 0. And it has to be proved that we have to prove that this p of x is representing, actually it is representing a PDF, probability density function. This function I will draw first. How it will be looking like? This will be looking like something like this. Okay, this is your x, this is your x, and this is your p of x. So first of all, you can see, you can have two observation. If you plot this function, you can have two observation. The first observation is that your p of x is always greater than or equal to 0, right? It is never negative. It is not negative. It is not negative. So the first property for the PDF is satisfied. That means a PDF should be always positive, and the area under the PDF should be equal to 1. Area means integral. It should be equal to 1. So the first condition, this is the first condition, this is the second condition. First condition is satisfied because all this p of x is a positive function. Now we will see. So this is the first condition. First condition is satisfied. Okay, now we have the second condition. First condition, and now is the second condition. We will integrate this p of x and see what is the area. If the area is less than 1 or if it is greater than 1, it is not a PDF. So we will see. You see, if minus infinity to 0, minus, you can say, is p of x dx. You see there is nothing. So this integral I can write only from 0 to infinity, because for x less than 0, the value of the p of x is 0. So I can write this integral 0 to infinity p of x dx. This is nothing but integral 0 to infinity x into e power minus x square by 2 dx. Okay. So I am going to integrate this. If this area is equal to 1, then it is a PDF, otherwise it is not a PDF. Okay. So integral minus infinity to infinity, sorry, not minus infinity, now it's only from 0 to infinity, and the p of x is, we have the p of x as x into e power minus x square by 2 dx. Okay. Now I want to integrate this. So for that I will put my t, I will introduce a new variable. T is equal to x square by 2. Then what is dt? Dt is equal to, what is dt? Dt is equal to 2x dx by 2. That means it is nothing but x into dx. So I will use this integral 0 to infinity. I have x into dx. So x into dx I will replace with dt. Okay, then e power minus t, x square by 2 is nothing but e power minus t. Okay, now you know that this integral is nothing but e power minus t divided by minus 1, which is nothing but e power minus t, this minus, and it's 0 to infinity. Okay, this is also like this, 0 to infinity. So this is nothing but e power minus of e power minus infinity minus of e power minus 0, right? So this term e power minus infinity is nothing but minus 1 by e power infinity, minus of minus means plus, and e power minus 0 is 1. But you know that 1 by e power infinity is, this is nothing but minus 1 by infinity, 1 by infinity plus 1, that is minus 1 by infinity plus 1. So what is this? 1 by infinity is 0, that means 0 plus 1, this is equal to 1. That means you have got integral p of x dx for all values of x is nothing but, that is, you are integrating from minus infinity to infinity, that is equal to 1, and your p of x is greater than or equal to 0. So this is the second condition and this is the first condition, both are satisfied. So your p of x is a PDF. that means probability density function, that means fx of x. Okay, now we will see okay, this is the first part of that question. I think only this part is there. Find the distribution, find the distribution of so we have to first show that p of x is a PDF of the. Now find its distribution function p of x. So we have to find it distribution function. What is this distribution function? So to find the distribution function, to find the distribution, I told you distribution means p of x is nothing but the fx of x here. So I will use the notation fx, that is better. So it is fx of x. Fx of x is nothing but integral 0 to, because we are starting from 0 because there is no value before 0 here for this particular distribution, integral 0 to x into e power minus x square by 2, okay, dx. Okay, this is, but usually we don't use the same variable, because you see here for the limit and for the integration variable both are using the same variable. So this is usually avoided in a standard general notations. So what we will do, this we will use as this thing I will use as another variable t and t, so t square by 2, okay, and I will also, this one I will just with respect to t, okay. So if you integrate this, you will get 1 minus e power minus, and after putting the limit x, this is your limit, then all this t will be removed and it will be, final answer will be in x, that's why. So 1 minus e power minus x square by 2 when x greater than or equal to 0. So this is my fx of x, okay, this is my answer, okay. I hope this is clear to you. Next we have another problem. So this is another problem. If there is a density function, it is given of a continuous random variable which is given as fx of x, okay, this is fx of x, you can say fx of x also is nothing but ax for the limit between 0 to 1 and it is equal to a for the limit between 1 to 2, and for 3a minus x 3a minus ax for 2 to 3 and 0 elsewhere, okay. Find the value of a. So this is given as a PDF. It is given f of x is a PDF. If it is a PDF, you know that the area under the PDF will be always 1, right? The area under the PDF, because it is showing the sum of all the probabilities, that is always equal to 1. So we will see what is the area. So here you see the function is defined only between these intervals, nothing elsewhere you see it is having a value 0. So we have to integrate integral 0 to 1, and what is the function value? Ax dx plus integral 1 to 2 your a, okay, into dx plus integral 2 to 3 3a minus ax into dx, this is equal to 1. So this will be always 1. So if you solve this equation, you can easily get the value of a. So you will get, if you solve this, you will get totally 2a will be equal to 1 and a is equal to 1 over 2. You will get this answer, a is equal to 1 over 2. Now you got the value of a. Now what is the second part of the question? The second part of the question is nothing but find the CDF of x. What is CDF? CDF means cumulative distribution function, that means fx of x. It is nothing but probability that x less than or equal to x. Okay, so the first part of the question is over. Now we will see the second part of the question. To find the CDF of x is nothing but probability that x less than or equal to x. How to find this? Integral minus infinity to x, okay, integral minus infinity to x fx of x dx, okay. But you see here our PDF is now, but we have fx of x as these values, right? We have got a equal to 1 by 2, but we have also a equal to 1 over 2, and fx of x is equal to 1 by 2 into x, because it was ax for the limit between 0 and 1, and is equal to 1 by 2, because you see in the problem it was a means we got our a as 1 by 2, right? So we will use this value here. So this was the value, this was the situation between 1 and 2, and it is equal to 3 by 2, that means 3a minus x by 2, and this was the situation between 2 and 3, okay. So we have to find the distribution. So we have three cases, you see, where I have three limits, 1, 2 and 3, okay, three cases here. So we will first see the case 1, this is case 1, this is case 2, and this is case 3. So we will see the case 1, because case 1 is nothing but x is between 0 and 1. So we have to integrate. If x is between 0 and 1, we have fx of x is nothing but integral 0 to x, okay. We have x by 2, usually this is x by 2 dx. Usually we will use the notation t to avoid the confusion, so dt, okay, there is no other issue. So this is actually, this change of variable is just for the integration. So you will get here as x raised to 4 by 4, okay, and you should know that x is between 0 and 1, okay, 0 and 1. Now we have case 2, we have case 2 now. So what is that case 2? In the case 2, x is between 2 and 1, right? So this is the, so fx of x is nothing but between 2 and 1 means you have to start from 0 to your x, okay, then you have to take fx of x dx, okay. So you have to use the dummy variable here. I told you about the dummy variable, so you have to use dt, okay. So this is nothing but integral 0 to 1, you have to first integrate, and between 0 and 1 you know the value was 1 by 2 into t dt plus, okay, integral from 1 to x, okay, because x is between 1 to 2, so you have to integrate from 1 to x also, and the value is 1 by 2 into dt, okay. So this is, okay, so it is, yeah, this is the answer. So you have to integrate this, and you will get this answer. If you integrate this, you will get this answer as x by 2 minus 1 by 4, okay, this will be the answer, okay. So it is because you see here in the case 2, we have the PDF something like this 0 and 1, and this is 2, and this is your 3. Your PDF fx was having 1 by 2 into x, it is a straight line something like this, and this is having 1 by 2, this is your PDF structure. So you are taking the point t here, so you have to integrate between 0 to t, from 0 to t, that means you have to take all the area under this curve till the value t. That's why we are using integral from 0 to 1. So 0 to 1 is fully covered, that's why we have completely covered this 0 to 1 here, from 0 to 1 here, and after that 1 to x. Okay, 1 to x. So sorry, not here, this is 1 to x. Okay, this is, so up to this point we have to cover. So here the dummy variable is t, that's why I am using a dummy variable here t. Okay, just changing the notation, that's it, for just for the integration purpose. Now we have case 3. So for the case 3, you know, our PDF is not ending here, our PDF is having some more things. That means 3a minus ax. 3a minus ax means it may look like something like this. Okay, 3a minus ax. Anyway, so I am going to take any point here now. This is my point x here. I am going to select the point x. X is between 2 and 3. So I have to find the fx of x. So I have to integrate from 0 to 1, 0 to 1, and 1 to 2, and 2 to x. Okay, this is, so that's it. I am using a dummy variable, that's what I am using, that's why I am using t here. So what was it? It was something like this is 1 by 2 into t, this is 1 by 2, and this is 3a, that means 3 by 2 minus x by 2. So not x, it's t, t by 2, 3 by 2 minus t by 2. So you are integrating like this. Okay, now for this I think your answer, you will get it as you will get this answer as 3 by 2 x minus x square by 4 minus 5 by 4. Okay, that's, you will get like this. This is the answer. So I hope this is clear to you. Next we will see another problem, problem 3. So this is the problem. You can see there is a continuous random variable with the PDF is given, fx of x is given, k into x square into e power minus x. You have to first find the k, that is the question. Then after that you have to find the mean of the random variable and the variance of the random variable. You have to use this property, that means you have to use the property of the PDF. That means you have the integral of PDF is always it is equal to 1, right? So we have to use this property. So you have the PDF, that means this is equal to integral, okay, so here there is a confusing statement here. This I am, x is between 0 and infinity. X takes the value 0 to infinity. X is between 0 and infinity. Okay, so it is 0 to infinity. Okay, and k into x square into e power minus x dx. Okay, this is equal to 1 anyway. So if you solve this, you will get 2k equal to 1, and k you will get it as 1 by 2. So this is will be your answer for the first part. Now you got your fx of x is nothing but k is 1 by 2 into x square into e power minus x. So this is your PDF. Okay, so your k is 1 by 2. We have already substituted here, you can see here. Okay, now we have to find the mean of the random variable. That is the second part of the question. You can see it's a mean of the random variable. So we will find the mean of the random variable is nothing but the expected value of x, which is nothing but integral minus infinity to infinity x into fx of x dx. But your PDF is defined only for x between 0 and infinity. Your x is between 0 and infinity. Okay, or x varies from 0 to infinity. X varies from 0 to infinity. X varies from 0 to infinity. This is your variation of for the x. So your mean is nothing but integral 0 to infinity, not from minus infinity, because your x is having a value only from 0 to infinity. So x is there, then 1 by 2 into x square into e power minus x dx. Okay, this you have to find. So this is if you integrate this, you will get it here as 1 by 2 times integral 0 to infinity x cube into, this is x square, okay, e power minus x square into dx. Okay, so if you integrate this one, you will get it as 1 by 2 integral x cube into minus of e power minus x minus 3x square into e power minus x plus 6x into minus of e power minus x minus 6 into e power minus x, okay, from 0 to infinity, and this answer you will get it as 3. Okay, this integration you can refer any textbook, or you can refer the Google to find how to integrate the exponential function. Okay, so this is your expected value of x. So the expected value of x is nothing but your mu x, you got it as 3. This is your average value. Okay, so your PDF may take this form. Your PDF is x into ex squared, that means it will be taking this form, and your mean average may be here somewhere. This mu x is equal to 3. Okay, this is your PDF structure now. Mu x is equal to 3. Now you have to find how much spread is there, that means the variance of this random variable. So how to find the variance? The variance is expected value of x minus mu x the whole square. Okay, so this you have to find it, or you can find it as the variance can be also find in another method. Variance is sigma x square. So sigma x square is nothing but expected value of x square minus expected value of x the whole square. This we have derived already in the previous lecture. So you know this guy, because expected value of x is already known to you. Expected value of x is mu x, which is nothing but 3 from the previous part of the problem. Now we will find expected value of x square. What is expected value of x square? It is nothing but integral 0 to infinity x square into fx of x dx. So this is nothing but 1 by 2 integral, okay, I will write the step, integral 0 to infinity x square into 1 by 2 into x into e power minus of did I make any mistake here? Okay, I have made a mistake here. This is only x, please. So this is also x and this is also x. Okay, I have made a mistake here, and yes, here it is. Okay, fine. Now x square into 1 by x, 1 by 2 into x into e power minus x, okay, dx. So if I integrate this one, I will get it as 1 by 2 into, this is x square is there already in the PDF. You can see x square is there, so that x square is there here. So x square into x square become x raised to 4. Okay, x raised to 4 into e power minus x dx. Okay, so if you integrate this, you will get it as 1 by 2 into x raised to 4 into minus e power minus x, okay, minus 4 into x cube into e power minus x plus 12 into x square into minus e power minus x, okay, minus 24 into x into e power minus x, okay, then plus 24 into x, sorry, 24 into minus of e power minus x, okay, and it's vary from 0 to infinity, and you will get it as 12. Okay, so you got it expected value of x square as 12 and expected value of x as 3. So the variance is nothing but expected value of x square minus expected value of x the whole square, right? It is nothing but 12 minus this is 3, so 3 square. Okay, so this is equal to 12 minus 3 square is 9, so it is equal to 3. So the variance of x you will get as sigma x square is equal to 3, and the answer for mean is also 3. Okay, so this is your final answer for this problem. So I hope this is clear to you, right? This problem is very clear to you. Now there is another problem. We will see another problem. We have 2 more problems from this session. So the distribution of a random variable is given. That means the distribution function, that means the cumulative distribution function capital fx of x is given. Fx of x is given as 1 minus 1 plus x into e power minus x, and x is greater than or equal to 0. Okay, we have to find the probability density function. Okay, so we have to find the density function. So you can see here this distribution function is a continuous function anyway, so we can find the density function. Then the probability density function is nothing but fx of x is nothing but d by dx of fx of x. So you differentiate this. So what will be the differential of the first term? Anyway, the differential of the first term will be 0, then there is a minus sign, then I will take the differential of this term, first term. Okay, then this is the second term. So 1 plus x, the differential of the first term is 1, so 1 plus x differential is 1 and into e power minus x, plus then you have 1 plus x and the differential of e power minus x is e power minus x is into minus 1. Okay, so it's nothing but minus here. So now you will get here this is minus here. Okay, so minus of e power minus x, then there is a minus here and a minus here, so minus minus become plus, so 1 plus x into e power minus x. Okay, so this will be your PDF. That means it is nothing but e power minus x plus x into e power minus x minus e power minus x. So you can see here this term and this term will cancel, so it is nothing but x into e power minus x. This is your fx of x. Okay, just differentiate. Now you got fx of x. Fx of x is nothing but x into e power minus x such that the x is greater than or equal to 0. This is your PDF. Now what is the second part of the question? Now that's what you have given here, you have got it. Okay, this I have written the answer here also, so you can refer both. Now find the mean and the variance of x. You have to find the mean and the variance of the x. How to find the mean of the random variable? The mean of the random variable is expected value of x. It is nothing but you have x here, then that means if this is x you have to multiply with x. Okay, then into fx of x dx. So this is nothing but, and you have to integrate. You see here it's varying from x greater than 0, that means x varies from 0 to infinity. So 0 to infinity x into, you have x into e power minus x dx. Okay, so this is nothing but integral 0 to infinity x square into e power minus x dx. Okay, so if you integrate this you will get the answer as 2. Now you will have to find the variance of x. Variance of x is nothing but expected value of x minus mu x the whole square, which is nothing but expected value of x square minus expected value of x the whole square. So we will first find expected value of x square. It is nothing but integral 0 to infinity x square into fx of x dx. Okay, so this is nothing but integral 0 to infinity x square into fx is nothing but x into e power minus x dx. So this is equal to integral 0 to infinity x cube into e power minus x dx. So you will get this answer as 6. Okay, now we will find what is the variance of x. Now we have the variance of x, which is nothing but expected value of x square minus expected value of x the whole square, and expected value of x square you have got it already, which is nothing but 6, and expected value of x was 2. So expected value of x square minus expected value of x, minus the expected value of x the whole square is nothing but 6 minus 2 square. Okay, so this is nothing but 2. So the variance sigma x square is equal to 2. Okay, so that is the answer for this problem. So you got it. So this is a simple problem. So you can expect these kind of problems for the exams also. So now we will see one more problem. This is problem number 5. This is a very beautiful problem. There is a random variable k. So the random variable is now denoted by k, not x. Okay, be careful, it is not x now, it is denoted by the k. Okay, so the random variable k, which takes the value small k. Okay, that's it. So you have to understand like this, and it is uniformly distributed over 0 to 5. Okay, it is uniformly distributed. That means the PDF is 0, it is between 0 and 5. The PDF is between 0 and 5. Now what will be, it is a uniform distribution, so it's uniform between 0 to 5. Now what will be this amplitude? This amplitude is nothing but, you see this width is 5, so this should be 1 by 5. Then the total area is nothing but, the area is 1 by 5 multiplied with 5. Then you will get only you will get 1. Okay, so if you have 5 here, then definitely the amplitude will be 1 by 5. Okay, definitely the amplitude will be 1 by 5. So this means this is 1 by 5. Okay, so the PDF fx of x is always takes the value 1 by 5. That's it. Okay, between 0 and 5. Okay, this is, and it will be 0 otherwise. Now what is the probability that the root of the equation 4x square plus 4kx plus k plus 2 is equal to 0? That means it is given an equation. You have an equation now given, an equation is given 4x square plus 4k into x plus k plus 2, this is equal to 0, and these roots should be, what is the probability that the roots are real? You know the probability for k, the probability density function for k is already known. Then what is the probability that the roots are real? It's a very, very good problem. So what is the probability that the roots are real? So first of all, we will see, first of all I will write the equation. The equation is 4x square plus 4kx plus k plus 2 is equal to 0. Now how to find the roots of an equation? That means ax square plus bx plus c equal to 0. Then what is the root of the equation? It is nothing but minus b plus or minus root of b square minus 4ac by 2a. This is the roots, right? The roots become real. That means the roots become, you should know this mathematics, otherwise you cannot solve this problem. The roots become real only if the square root term b square minus 4ac, that means the square root term, this square root, that means this number should be greater than or equal to 0. If it is less than 0, then it becomes square root of minus something negative. The square root of something negative is a complex number. So the roots will be real only if this number is greater than 0. So we will say what is here b. Our B for this problem, B is 4 into k, and our A for this problem is 4, and our C for this problem is k plus 2. You can compare this thing, this is and this part, and you can compare this part. Okay, so our B for this, now we will find B square minus 4AC. Okay, B square minus 4AC, B square minus 4AC. B square minus 4AC is how much? B square minus 4AC is nothing but 4 square k square, that means 16 k square minus 4, A is 4 into C. What is C? C is k plus 2, right? This should be greater than 0, greater than or equal to 0, right? This should be greater than or equal to, that means 16k square minus 16 into k plus 2, right? 16 into k plus 2 should be greater than or equal to 0. That means I can write in another way also, k square minus k plus 2 should be greater than or equal to 0, or k square minus k, because 16 is common here and right side is 0, so you can divide by 16 both sides, then you will get k square minus k plus 2 greater than 0. That means k square minus k minus 2 should be greater than or equal to 0. So this is the first part of this problem. So this number should be greater than 0. That means you can find the roots of this. What are the roots of this equation? It can be k minus 2, okay, it can be k minus 2 and k plus 1, right? You can split this equation. This should be greater than or equal to 0. This will be greater than 0 is the main core part idea of this problem. So I will write it in the next page. K minus 2 multiplied with k plus 1, I think k plus 1, right? Yeah, k plus 1 should be greater than or equal to 0. That means your k have different choices. If you consider this choice, if you consider this as positive and this as positive, then the roots will be also greater than 0. That means your k minus 2 greater than 0. That means your k is greater than or equal to 2. This is the first part. And because these are satisfying simultaneously, and okay, now and will come, and k plus 1 should be greater than 0. So this is our condition. So k plus 1 greater than 0. This means that k should be greater than minus 1. Am I correct? Yes. Or we have another choice also, not only this choice, we have another choice. This is one choice. Another choice is another choice. You have k minus 2 into k plus 1. This product should be greater than 0. That means you can have this as negative and this as negative. Okay, you can have this as negative and this as negative. Then this will be what? It will be positive. That means your k minus 2, less than or equal to 0. That means k should be less than minus 2. Okay, that means k should be less than minus 2. K should be less than or equal to minus 2, and this is very, very important. Both should satisfy simultaneously, otherwise it's a problem. Otherwise the condition will not be satisfied. Next, k plus 1 should be less than 0. K plus 1 should be less than 0. Less than or equal to 0. That means k should be less than or equal to minus 1. Okay, so we have these condition. So we have the total condition, we can say the total condition which may affect the probability that the roots become real. We have k, the probability that k greater than or equal to 2 and probability that k less than or equal to minus 1. Or we can have another condition, this is and anyway, or we can have another condition, the probability that k less than or equal to 2 and the probability that k less than or equal to minus 1. Now we will decide. Our PDF is having a property, you know, our PDF is like this. Our PDF, I will show you our PDF for k was 0 to 5, okay, and this is 1 by 5 is the amplitude, okay, 1 by 5 is the amplitude. There is the probability, there is, you see here, the probability that k less than minus 1. What is that probability? The probability that k less than minus 1, sorry, it's k greater than plus 1. This is, I have made a mistake, this is plus, so this is greater than or equal to, okay. We have two conditions now, that means probability that k greater than 2 and probability that k greater than minus 1, okay, as this condition, the first condition, and the probability that, or you can see this is or, the probability that k less than 2 and the probability that k less than minus 1. You know that the probability that k greater than 2 and probability that k greater than minus 1 means it is nothing but probability that k greater than 2, because if k is greater than minus 1 and probability that k greater than minus 2, both should be satisfied only if the probability, if the k is greater than 2. If k is greater than 2, then the k is greater than minus 1 will be also satisfied. So you can say that this can be written as a single probability, that means probability that k greater than 2, okay, this plus, okay, plus, because this is or means plus, probability that k less than 2 and k less than minus 1, that will never happen, because if something is less than minus 1, okay, if something is less than minus 1, then this probability is 0. So probability that k, the probability that k less than or equal to 2 multiplied with 0, so this term becomes 0. So you are having the total probability that k greater than or equal to 2. So we have probability that k greater than or equal to 2. This is nothing but, you have to integrate the PDF. The PDF is PDF from 2 to 5 fx of x dx, okay, and this is 2 to 5. And what was our fx? Fx was having a value 1 by 5 dx. So this become 1 x by 5 between the limit 5 and 2. So this become 1 by 5 into 5 minus 2 become 3 by 5. So the probability that the roots of the equations may become real is 3 by 5. So that is the answer, 3 by 5. Okay, I hope this is clear to you. Thank you.